using the quotient rule to find the derivative of a rational function or a fraction where you have x in the numerator and x in the denominator. And so because of that, this is going to be really the only option you have for finding the derivative. If there was only a number in the numerator, you could actually do it with the quotient rule, or you could do the chain rule. But once you have an x in the numerator, you know that you have to do the quotient rule. So let's go ahead and make a list here, and so we can use this formula because we have this f prime g minus fg prime, so we have the derivative of f times g minus f times the derivative of g divided by g squared. Okay, so if f is negative 4x, back to this problem, then f prime will just be negative 4. Then we have g over here, we have x cubed plus 2x squared. Well, if I take the derivative of that, it's just going to be 3x squared plus 4x. Okay, so now I can go ahead and input this all into my formula so that I can have my derivative using the quotient rule. So f prime is going to be negative 4, and then I'm going to take my original denominator, x cubed plus 2x squared, so minus, and we'll deal with this in a second because we're going to have a negative 4x times g prime, which is 3x squared plus 4x. All right, so let's go ahead and then we're going to put that all over g squared. So, you can multiply this out because you're going to just take this whole thing and put it in parentheses and square it. But I like to leave this as my final answer because unless I'm going to, even if I'm going to input a number, it's actually a little easier to do it in that form. So now we're going to have we're going to go ahead and start distributing here. Negative 4x cubed times negative 4 times 2x squared is going to leave me with negative 8x squared. Now here, right, I'm going to rewrite this. Well, actually, let's just think about the fact that the negatives cancel out. So I have positive 4x. And so I really have positive 4x times 3x squared, which is going to leave me with plus 12x cubed. And then I have positive 4x times 4x, which is going to leave me with 16x squared. Okay, so we'll be able to combine those in a second. But in the denominator, I still have the same thing. I have plus 2x squared, quantity squared. Okay, so final step I'm going to do here is combine my like terms. I got negative 4x cubed plus 12x cubed. That's going to leave me with 8x cubed. And then I have negative 8x squared plus 16x squared, which is going to leave me with plus 8x squared. And like I said, I prefer to just leave the denominator in parentheses squared. And we're done with this one. All right, let's look at another one here. Let's look at kind of a similar case, but will be a little bit different here. And so let's start by making our list here. We're going to have x cubed minus 2x. We're going to have f prime be 3x squared minus 2 then. And then g will be 3x squared plus 4x. So g prime will be 6x plus 4. And let's go ahead and I'm going to go ahead and do my derivative over here because we might need a little room for this one. Okay, so we're going to have f prime g minus fg prime. So we're going to have 3x squared minus 2 times g, which is 3x squared plus 4x, minus fg prime. So that's going to be x cubed minus 2x times g prime, which is 6x plus 4. Right, so this is going to get rather long for a second here, but it'll get easier in a second. Now in the bottom, remember, we always have g squared, so we're going to have this. All right, so now we're going to go ahead and multiply everything out. All right, so we're going to get 9x to the fourth. I like to distribute the 3x squared to this term next, so that's going to be 12x cubed minus 6x squared minus 2 times 4x is minus 8x. And now when you do these, you just got to think like really this is negative x cubed times 6x. So that's negative 6x to the fourth times negative x cubed times 4 is just negative 4x cubed. Then we have minus minus will be plus 2x times 6x, which will give me 12x squared. And plus again 2x times 4, which will be 8x. Okay, now we got a lot of stuff to combine here. So just keep in mind this is all over 3x squared plus 4x quantity squared. So go ahead and combine a bunch of like terms here. We're going to get, let's look at what we get. We're going to get, so I would start with the largest power first. 9x to the fourth minus 6x to the fourth is going to leave us with 3x to the fourth. And now I'm just going to go to the next one down, which is cubed. I got 12x minus 4x cubed. So that's going to leave me with positive 8x cubed. So I'm going to go ahead and keep crossing things out as I've accounted for them. And then I'm going to get negative 6x squared plus 12x squared is going to leave me with plus 6x squared. And then I got minus 8x plus 8x. So that cancels out, right? So that's kind of nice. We get, this is all of our terms left here. We got minus 8x plus 8x cancels. And now we can just write our denominator. And again, I like to just leave this in parentheses squared. And we're done with this one. Okay, let's look at one more here with an ln of x. So we got a special case, right? So I'm going to go ahead and write this. And, there's going to be some things we can simplify here and some we can't do a whole lot with. But let's go ahead and set this up. We got f is going to be ln of x. And f prime is going to be 1 over x. Or you might like to think of it as x to the negative 1. Then g is going to be x to the fourth plus 3x squared. And g prime is going to be 4x cubed plus 6x. Okay, so I'm going to go ahead and set up my equation here. Input it into my formula, f prime g minus fg prime. So we're going to do f prime is going to be x to the negative 1. And that's going to get multiplied by x to the fourth plus 3x squared minus fg prime. So we got minus natural log of x times 4x cubed plus 6x. Okay, so this is all going to be over our denominator, which is just the quantity of g squared. Okay, so if I look at this one, I got x to the negative 1 times x to the fourth. That's going to leave me with x cubed. I'm just adding the exponents again. And then I got x to the negative 1 plus 3x squared, or times 3x squared. That's going to leave me with 3x to the first. And really, like, you could maybe do something with this, but it's natural log of x times this quantity. So I'm just going to go ahead and leave it, because if I go ahead and start multiplying out, it actually makes my answer longer. And then this is all going to be over x to the fourth plus 3x squared quantity squared. And now we're done with this one.